If you have heard about NC axis and you wonder what is it about, this short video will try to provide a summary explanation of what it is. An NC, meaning numerically controlled axis, is a component in automated machinery that controls movement along a single axis, such as side to side or up and down. On this moving red plate, a tool holder or a gripper or another axis can be mounted. This plate is mounted on dovetail slides, as one can see it in this case. These can also be linear bearings or V-groove bearings. These slides are mounted on profile rail guides and can slide in both directions. To drive these slides, we will be using an electrical motor, usually a servo motor, which is made of an electrical motor to generate the mechanical power, and an angle encoder to follow the motor angle and the number of rotations. If needed, a gearbox can be connected to the motor. The rotation movement is converted to a linear movement using a ball screw and nut, or using lead screw and nut, or using a rack and pinion system, or like in our case, using a timing belt and pulley. This way, the linear movement is transmitted from the motor all to the moving plate. To prevent damage, the movement is limited on both sides using bumpers. To control the motor, we need to connect it to a servo controller, usually using two cables, one for the motor power and the other for the encoder signal. Currently, some providers offer systems using one cable for both functions. Next, we are going to add two inductive limit switches on both sides to limit the travel path and avoid often bumping, which can damage the machine. The limit switches are usually connected on special inputs of the servo drive as normally closed switches to detect cable break. Each time a limit switch is activated, the drive controller issues an error and stops the movement. Now, all the hardware of the axis is set up and we can start controlling it. For example, using a PLC connected to the servo controller through a real-time bus system. First, we can set more tight limits on the travel path using software limit min and max values, allowing a smooth motion control of the axis. Then, we can send movement parameters and commands from the PLC to the servo controllers, and that's almost it. If you liked the video, subscribe to the YouTube channel and learn more about machine control.